I'm focusing on understanding least angle regression, a technique in scikit-learn, a popular Python library for machine learning. Lars helps me find the best way to fit a linear model to my data. It's a bit like finding the best line through a scatter plot of points, but in a clever, efficient way. This question tests my knowledge of the _Lars_path function. I need to understand what information this function gives me back. It's like asking a multiple-choice question about the tools I use for a specific job. I see the word flow. It implies that the Lars algorithm follows a sequence of steps. Think of it like a recipe. I start with something, follow the steps, and end up with a result. The algorithm needs data, like numbers in a spreadsheet, to work with. This is my starting ingredient in this recipe. We start by picking the biggest possible value for ALPHA. ALPHA is a parameter that controls how much we want to shrink our model's coefficients to prevent overfitting. It's like setting the initial temperature for a process. I'm dealing with a matrix, which is like a spreadsheet with rows and columns. Each column holds the coefficients. The coefficient tells me how much each variable influences my outcome. This statement is about the first column of my coefficients matrix. It says it relates to when there's no regularization, alpha equals 0. I want to make sure I understand whether the _Lars_path function always finds the best answer for a linear regression problem, given enough data. I am using the function _Lars_path. It gives me a sequence of ALPHA values. These ALPHA values decrease from the largest to the smallest. I start the least angle regression, Lars, algorithm by setting the regularization parameter alpha to its largest possible value. Think of alpha as a tuning knob controlling how much I shrink the coefficients. A large alpha means a lot of shrinking, leading to a simpler model. I iteratively add variables to the model, one at a time. I select the variable most correlated with the remaining errors, residuals, from the previous step. This means I am always trying to add a variable that explains the unexplained part in the data most accurately at the moment. After adding a variable, I gradually decrease the value of alpha. This means I'm slowly relaxing the constraint of shrinking the coefficients. The smaller alpha gets, the more influence the data has on my coefficient estimates. For every alpha value, I record the corresponding estimated coefficients for each variable in the model. This creates a path of coefficient values across different levels of regularization. I stop the algorithm when I have included all variables or reached a predefined stopping criterion. At that point, I have my full set of coefficients across the range of alpha values. That's all, folks. I'll start by initializing the least angle regression, Lars, algorithm. Think of it like setting up your starting point before a race. Next, I'll iteratively decrease alpha. Alpha controls how much I'm regularizing, or simplifying, the model. Imagine it as a knob that slowly reduces the complexity of the solution, allowing more features to impact the results as it decreases. Finally, I'll output the alphas, the sequence of regularization parameters I used, and the cofs, the corresponding coefficient values for each alpha. These outputs will form the basis of understanding how the model's complexity and the feature weights changed during the Lars algorithm's execution. During each iteration, I'll select variables to add to the model based on their correlation with the remaining unexplained part of the data, residuals. I update the coefficients accordingly, iteratively refining the model's fit to the data. The core question is, what are the facts about the outputs, alphas and cofs, produced by the scikit-learn's _Lars_path function when applying least angle regression? The question focuses on interpreting the alphas and cofs returned by the least angle regression, Lars, algorithm in scikit-learn. We'll consider which statements correctly describe these outputs. I'm analyzing the output of the least angle regression, Lars, algorithm, specifically focusing on how the regularization parameter, alpha, influences the estimated coefficients. I will explore the relationship between these key outputs, alphas, regularization parameters, and cofs, coefficients. I'll be examining what these values mean in the context of the algorithm. The Lars algorithm is an iterative process. It starts with a large regularization parameter, alpha, which means a lot of regularization and thus, Simple model. As the algorithm progresses, alpha gradually decreases. With each decrease, the model complexity increases, and more variables are included. This iterative addition of variables continues until it finally reaches a stage when there's no regularization at all. At this point, you have the ordinary least squares, OLS, solution, the best model according to the data. Think of it like building a model with Legos. You start with a few basic bricks and add more until you reach the optimal structure. This is a multiple choice question testing my understanding of the *lars_path function's output. The *lars_path function is within the scikit-learn library, which is a popular machine learning library in Python. I need to assess the accuracy of each statement concerning the function's output, *alphas, regularization parameters, and *cofs, coefficients. I need to correctly identify what each represents. This statement describes the order in which the *alphas, are generated and used during the Lars algorithm. I must check if this is accurate. They start large and decrease. It's like gradually reducing the strength of the regularization. This statement describes the structure of the *cofs, output. The statement says that each column corresponds to one alpha value. I'll confirm if this column-wise organization of coefficients is correct. Each column contains coefficients associated with a particular regularization strength. This statement asserts that the first column of the *cofs, matrix contains the coefficients for the case when there is no regularization, alpha equals 0. I'll check if this interpretation is correct. This is an important check to see if I fully understand the alpha-cofs relationship. This statement claims that the *lars_path function always produces the exact solution to the linear regression problem for an adequate dataset. I'll verify whether this claim is entirely true. It's important to consider the implications of numerical precision and iterative methods. Okay, let's dive into least angle regression, LARS. Imagine you're trying to fit a line to a bunch of scattered points. LARS is a clever algorithm that does this step by step, adding variables to your model one at a time. It focuses on the variables most correlated with what's left unexplained by the current model. We'll analyze its output shortly. This question tests your understanding of what Lars gives you back after it's done crunching numbers. Specifically, we'll be examining the alphas and cofs outputs. Are you ready to tackle some true, false questions about these? The *alphas, output is a list of regularization strengths used during the Lars process. Think of each alpha as a dial controlling how much we're penalizing the model for complexity. A high alpha means we are heavily penalizing complexity, resulting in a simpler model. We start with a high alpha and gradually decrease it, allowing the model to become more complex as we proceed. It's like gradually turning down the complexity dial. The *cofs, output is a collection of coefficient estimates. Each column represents the estimated coefficients for a given alpha value from the *alphas, list. It's like a time lapse of the coefficient values. Each column shows you how the coefficients changed as we decreased the regularization, alpha. I wish it were true. But unfortunately, *lars_path doesn't always find the absolute perfect solution. Because of the iterative nature of the algorithm and small rounding errors in computers, there's always a tiny bit of imprecision. It gets extremely close, but perfection in floating-point arithmetic is a rare beast. This statement is incorrect. The first column of *cofs, corresponds to the coefficients obtained with the largest alpha value, not alpha equals 0, no regularization. The solution with no regularization, alpha equals 0, is found at the very last column. It's like the final frame of the time lapse. This section introduces the core topic, analyzing the output of the least angle regression, LARS, algorithm, specifically focusing on understanding the relationship between the regularization parameter, alpha, and the estimated coefficients. I'll guide you through the interpretation of the *lars_path function's results in scikit-learn. Let's get started. This section will describe the steps the Lars algorithm takes to find solutions. It will help contextualize how the *alphas, and *cofs, are generated. Think of Lars like a stepwise approach. It builds a model gradually adding predictors, variables, one at a time, depending on their correlation with the data's remaining unexplained variance. I'll walk you through this so that you'll understand why the output looks the way it does. Here we'll dive into the meaning of _alphas_, which is a crucial output of the _lars_path function. I'll explain how it represents the sequence of regularization parameters used during the Lars algorithm and why its values decrease in magnitude, going from the largest to the smallest. Remember, alpha controls the model's complexity, a larger alpha simplifies it, and smaller values make it more complex. This section focuses on the interpretation of _cofs_, which contains the estimated coefficients for each alpha value. Think of this as a table showing how the model's parameter estimates change as the regularization strength decreases, alpha decreases. I'll explain how to relate each column to the corresponding alpha value. This is where we link the alpha values to the estimated coefficients that the Lars algorithm returns. This is the central question of the quiz. It's asking you to analyze and interpret the results of the _lars_path function within the scikit-learn library. I want you to understand what is expected out of the function output. The question directs you to evaluate the correctness of various statements related to the function's output. I see _alphas_ as a list of numbers. Each number represents how strongly we're penalizing the model's complexity. A larger number means stronger regularization, and a smaller number means less regularization. The _lars_path function starts with a large alpha and gradually decreases it step by step. Think of it like this. Imagine you are baking a cake. The regularization parameter is like the amount of flour you add. Too much flour, the cake is too stiff. Too little flour, the cake crumbles. The _alphas_ list shows the different amount of flour being used during this process. Isn't that interesting? The _cofs_ is a table of numbers where each column shows the best model parameters for a specific alpha value from the _alphas_ list. Each row in this table represents a different variable in the model. For example, you may have variables like age and income, and you can see how much each variable impacts the prediction for each alpha value in _cofs_. I think of it as a record of how the model parameters changed as I gradually decreased the regularization. So cool, right? This is the main question of the quiz. The question is asking you to figure out which statements about how the _lars_path function outputs data are true. Let's get into it. This refers to the least angle regression, LAR, algorithm. It is a regression technique that builds a model by adding variables one at a time. It efficiently handles situations with high dimensionality, thus offering a powerful solution for complex datasets. The _lars_path function implements this algorithm. It's a really smart algorithm.